Okay, on this sheet, the first one is a coconut drops of tree lands going 14. How high was the tree? So looking for the distance. Okay, well, first we would need we can use VAT to get the time. So the time would be the change in V, which is the 14 divided by the acceleration due to gravity. Once we have that, we can use DTV with the time we just found and the average speed of the fall, and that will tell us how high the tree was. The next one, a skydiver is floating down, accelerating at 0.52. What force is the parachute using to slow him down? Well, let's see. First of all, I can find his force of gravity, which is the force pulling him down. So I got his mass, and I know what G is. I have his acceleration, which means I can find his net force, which is going to be MA, which apparently is also going down. So then all I'd have to do is find the difference between the two. I know how much he's supposed to be going down with, his force of gravity. I know what he is going down with, that's his net force. So whatever is missing must be the force that the parachute is using to slow him down. All right. So next we have Spider-Man falling from building, and he's going to shoot a web after 3.8 seconds, stretches 7.4, looking for the tension of the web when it slows him down. Okay, well, first things first, if he's falling down and he uses a web to slow him down, there's going to be a lot of tension on that web, because the acceleration, even though he's going down, he shoots his web and slows himself down, he's slowing himself down, which means the acceleration is actually up, because he might be going down, but he's slowing down, so the acceleration is the opposite direction. Okay, well, let's start with first things first. He falls for 3.8 before he even shoots the web. So I can find out his change in V on the way down. So I can find out how fast he was going when he shot the web. Then I know he goes from that speed to 0. So if I know he goes that speed to 0, I can find the average speed during the stopping part. And if I have the distance of 7.4, I can find the time it took him to stop. And if I know the time it took him to stop, I can find the acceleration that was used in order to slow him down by doing the change in V, using the answer I got from the V equals GT at the top, and dividing by the time I just found to find the acceleration of Spider-Man when he was slowing down. So then to find the tension, of course, that's forces. Now, he's going down, the web is pulling up, slowing him down. So the first thing is the web has to pull with enough force just to support his weight, because if the web couldn't even support his weight, it would just have torn already. And then it also adds some more force, MA, to actually slow him down using the acceleration that we'd found in the first part. So then the total tension of the web should be the combination of those two put together. All right, for number 4, we have the 6 donuts, looking for the normal force between the second and third donut. Second and third donut from the bottom. Now, first of all, the bottom 2 donuts have nothing to do with anything, because if the top 4 donuts weren't on there, there would be no normal force. So the only reason that there's normal force between 2 and 3 is because you're pulling up on it. You got the weight of the donuts up top weighing it down. So first of all, if you would take those 4 donuts, if you find the force of gravity for all 4 donuts on top of it, so this is for all 4 donuts, if you find the weight of those donuts, that's how much normal force there would be just if the plate was standing still. But it's not standing still, you are pulling up on the rope, which means you're going to have more force, more normal force, more pressure, just like an elevator type question we've done before. So if you then do the F equals MA for those 4 donuts and be the mass of all 4 donuts put together, you could find the net force that's actually being used to accelerate all 4 donuts. So to get the normal force in between where the arrow is pointing, well, first of all, you need the weight of all 4 donuts put together on top, plus the net force F equals MA of all 4 donuts put together on top, and those two put together should be the normal force in between the donuts where the arrow is pointing. All right, so next we go on to where there is some tension questions with hanging hanging stuff. So the first one here, we've got Batman is hanging from rope inside of a building. He's 92. What's the tension on the rope? Okay, well, of course, there's two main forces. We got a triangle, we got the force going down, and we got the force going sideways, which is actually a normal force between him and his feet, and then the rope. So, of course, it just makes a right triangle, something like this. This side, the vertical part, is due to his weight pulling straight down, so you can find that part right there. You have the angle of 38 degrees. It is just a right triangle. So then you can use your basic trig in order to figure out what the hypotenuse would be, and that is what the tension should be. For the raccoon question, very similar. We've got a force at an angle. So the first thing we should do is we should break that apart. And you'd find the vertical component, the horizontal component. We know the horizontal components have to be the same, so we just make those equal to each other. You've also got the weight of the raccoon, so you can find out how much is pulling down. And then we know the two vertical components, the one over here and the one there, have to add to the weight, so you can find out how much vertical component is missing from the weight. You've got the x component from the left side is equal to the right side. Find out how much vertical component is missing from the weight, depending on what your value is on the left vertical component. You then have the horizontal, you have the vertical, and use those two to find the missing angle. And the last one, similar-ish. Okay, you'll find the mass of the person, very similar to the raccoon. You can break the 720 apart, find the vertical, find the horizontal. You know the horizontal has to be equal because it's not moving sideways at all. And then you can use the 60 degrees. It is, again, just a right triangle. Use that 60 degrees to figure out what the missing vertical part is. Take the two vertical components, add them together, and they will give you the weight of the person. And then once you have his weight, divide by the g value to get the mass of the person.